In this video, we'll be learning about trigonometric functions and how they work using right angles and points on a graph. We will also learn how to tell if the values are positive or negative depending on where the angle is. Let's get started. Alright, so trig functions are based on ratios of sides in a right triangle. I'm sure you've all seen SOHCAHTOA before. So, if you don't know what it means, the first part, so, it stands for sine. The second part stands for cosine, and the third part stands for tangent. And so sine is equal to opposite over hypotenuse. And I have it all written over here, opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. And now you see these new values on the right side that you may have not seen before. These are the reciprocal values of sine, cos, and tan. So basically what this means is that this value cosecant is 1 over sine, this value secant is 1 over cos, and this value cotangent is 1 over tan. So with that being said, when you are looking for a value of cosecant, you're going to flip your sine values. So if we look at our SOHCAHTOA here, we see sine is opposite over hypotenuse. So the reciprocal cosecant is going to be hypotenuse over opposite. And for cosine, we see adjacent over hypotenuse. The reciprocal secant is hypotenuse over adjacent. And for tangent, we see opposite over adjacent. And the reciprocal cotangent is adjacent over opposite. So before I move on to an example on a graph, let's do a quick example of what I just taught you. So if we see our tan value is -5 and we want to find the cotangent value, well, we know that the cotangent value is going to be 1 over tan because it's the reciprocal. So 1 over 5, and it's negative. And now I'll show you what it looks like on this triangle. So let's say our angle is right here. So the opposite side is going to be right over here because it's right across from the angle. Now our hypotenuse is always this line here on an angle, so we write that as hypotenuse, and our adjacent side is going to be right beside the angle. So let's say, for example, if this is 3, this is 5, and this is 7. If I ask you what is the cosine value of this graph, we know that cosine is adjacent over hypotenuse. So from our angle, the adjacent side is 3. And the hypotenuse side is 7. So therefore, our cosine value is 3 over 7. Now, let's say I ask you for the secant value. If we have our 3, our 5, and our 7 again, it's just going to be the opposite of what we did for our cosine. So, if we refer to our SOHCAHTOA here, we can see secant is hypotenuse over adjacent, which is going to be our 7 over our 3. And there you have it. Alright, now that we've got those fundamentals down, we can move on to the second part, which is just where we're going to change our regular values of opposite, adjacent, and hypotenuse to a y, x, and an r. Now this is pretty simple because we know that when we look at a graph, our y value is the vertical line and our x value is the horizontal line. And our r value is just going to be the same as hypotenuse because it's the one on the angle. So if we refer to our chart over here and we look at our angle, we can see the sine value, which would normally be opposite over hypotenuse, has just been changed to y over r. And this would be the same for our cosecant value, which is normally hypotenuse over opposite, and that has just been switched to r over y. Alright, so now we move on to the next part, which is quadrants. So When we see a graph like this, there's 4 quadrants. So quadrant 1 is going to be right here. Quadrant 2 will be right here. Quadrant 3 right here. And quadrant 4 right here. So we have an abbreviation or a phrase, all students take calculus. And this is going to be used for our quadrants here. So we're going to write it counterclockwise. A, S, T, C. All students take calculus. And this is quadrant 1, this is quadrant 2, this is quadrant 3, and this is quadrant 4. Alright, so what this means, so this A stands for all, which means everything can be positive in this quadrant. The S stands for sine, the T stands for tangent, and the C stands for cosine. So what this means is that if you have sine, it's going to be positive here. If you have tangent, it's going to be positive here. And if you have cosine, it's going to be positive here. All of these are going to be positive in the all section. So, with that being said, if you are given a sine question, we'll know that it's going to be positive in the sine quadrant as well as the all quadrant. So these two right here. That means that it's going to be negative in the tangent and cosine quadrant. So it will be negative here and positive here. Now let's say you have a tangent. So we know tangent is positive in the all. We also know it's positive in the tangent quadrant. So where do you think it's going to be negative? It will be negative in the sine quadrant as well as the cosine quadrant. Alright, we'll do one more example for this one. Let's do cosecant. So CSC. Cosecant, if you remember from our graph, is just the reciprocal of sine, which means hypotenuse over opposite. Which means we will be looking for a sine value. We want our cosecant to be positive, so we're going to look, where is sine or cosecant positive? Well, we know it's going to be positive in the all, and we also know it's going to be positive in the sine. So both of these will be right. Quadrant 1 and quadrant 2. Let's say I'll ask you to find, where is cosecant going to be negative? Well, if sine is positive here and here, then it must be negative here and here. So let's try an actual question from the workbook now. So this question says, determine the quadrant in which theta is found. It says sine theta is less than 0 and tan theta is less than 0. So from this we know that both sine and tan are negative. So we're going to go look at our graph now, and we're going to draw out our all students take calculus. So first we have sine being negative. So we know it's not going to be here or here because these are both positive. So it will be in one of these. We also know that our tan is negative. So it's not going to be here and it's not going to be here. But it can be in one of these. So we've now found that 2 of our points are in the cosine quadrant, quadrant 4, which means that is our answer. Alright, let's try another one. So for this one, we have sine greater than 0 and secant greater than 0, which means both of these values are going to be positive. So if we look at our graph, our first is sine. Sine is greater than 0, so we know it's going to be positive in the all section and in the sine section. So we can put our 2 points down there just to remember. Our next value is secant being positive. So we know that secant is the reciprocal of cosine. And if our cosine is positive, it's going to be here and here. So now we see that both of our values are positive in the all quadrant, which is what we were looking for. Our sine greater than 0 and our secant greater than 0, which means our answer is quadrant 1. Alright, let's look at a slightly more tricky question now. A point on the terminal side of theta is shown. Evaluate the 6 trigonometric functions of theta. So we can see in the graph that this triangle has a point for us. So let's move over here. When we look at the point 4 and 3, we know that this is the x value and this is the y value. So we'll put our 4 right here, our 3 right here. Now what we need to do is find the hypotenuse. We can find our hypotenuse by using a squared plus b squared equals c squared. So we'll fill in our values really quick. So 4 squared turns into 16, 3 squared turns into 9. Add those together to get 25, and then square root both sides. And then you are left with 5 as your c value. So we know that our hypotenuse is 5. We're going to put that down right there. Alright, now that we have all of our sides of the triangle, we can start working on the main question. Now this wording here might seem confusing, but not to worry, it's way easier than it looks. So first we'll start off with our sine value. So if we look at our SOHCAHTOA, we know that sine is opposite over hypotenuse. So we're going to be looking from this angle right here. The opposite side we can see is 3 and the hypotenuse is 5. Therefore, our sine value is 3 over 5. Now we'll move on to the tan. So our tan is opposite over adjacent. So opposite is 3, adjacent is 4, making our tan value 3 over 4. And for secant, we know that secant is the reciprocal of cosine. So we look at our cosine and then we read it backwards. So hypotenuse over adjacent. Look at our thing. Hypotenuse is 5, adjacent is 4, meaning our secant is 5 over 4. And for cosine, that will be adjacent over hypotenuse, so 4 over 5. Now that we've done all of that, we don't necessarily need to keep checking them out because we know cotangent is reciprocal of tan. So we can just make our cotangent answer 4 over 3. And we can make our cosecant value 5 over 3 because cosecant is the reciprocal of sine. And there you go. Just like that, the question is all finished. Alright, this is the last question we will be doing before we wrap up the video. The value of one trigonometric function is given. Determine the other 5 trigonometric functions. So we've got sine theta is 5 over 13 if theta is in quadrant 1. So let's go look at our graph. We know the question tells us that it's in quadrant 1, so we'll drop our triangle down there. Now, sine, which we know is opposite over hypotenuse, is 5 over 13. So we look 5 over 13. This is our opposite. Boop. And this is our hypotenuse. Boop. Now we've got to use quadratic formula again to solve for our missing side. So we've got our a squared plus b squared equals c squared. Now we're going to fill in our values. We know that our a or b value is going to be 5 because it's right here. And our c value, which is the hypotenuse, is 13. Now we have to arrange this to solve for our b value. You know what? Before that, let's just put in our proper numbers here. 5 squared is 25. 13 squared is 169. Now we need to move our 25 over here, so we're going to minus 25 from this side and minus 25 from this side, because what you do one side you have to do to the other. This leaves us with b squared equals 144. Now all it's left to do is square root both sides, which leaves us with b equals 12. And then we write that right there where our missing side is. Okay, now that we have found our missing side, we can begin to get our values. So we already know that our sine value is 5 over 13 because the question gives it to us. So now we'll do our tan value next. So we look at our SOHCAHTOA again. Tan is going to be opposite over adjacent. We see our opposite side is 5 and our adjacent side is 12. Therefore, our tangent value is 5 over 12. Next, we'll do our cosine value, which is adjacent over hypotenuse, 12 over 13. Now, we already know we can get these three values just by flipping these numbers, but we'll go ahead and find the cotangent value using our graph, and then we'll do that for the other two. So cotangent is the reciprocal of tangent. So we look at our tangent and we flip them. Adjacent over opposite, which is going to be 12 over 5. Alright, now let's just go look at our secant. It's going to be the reciprocal of cosine. So we'll just flip this around to 13 over 12. And we can do the same thing for our cosecant value. It's the reciprocal of sine. So flip this around and we get 13 over 5. And that's it. The question is solved. So we now know how to get all of our values when we get given a value as well as given a point on the graph. That wraps up our lesson on trigonometric functions of acute angles. Hopefully this helped, and I'll see you in the next one.